You're gonna have to like shine it over at me. I'm not gonna.
All right, I'm starting the recording. Okay, so again, here's my dad. His name's Tom, and yeah, we're gonna talk about my project. Let's get what we can look at going here. So again, yeah, just go over my project. You know, it's an application that uses machine vision to operate some sort of controller. So here we have a camera here. Here's my dad, by the way. So yeah, the application is we're trying to use machine vision to operate some kind of controller. Can you see? Okay, turn on the brightness. And in order to do so, there's a couple different techniques that we can use. There's actually a lot of different techniques that we can use. We just explored like 2 of them. The 2 that we explored is called background subtraction and KLT tracking. I'll talk about it a little bit more. But again, if you have any questions, just feel free to let me know. But let's just look at the first one. Well, actually, yeah, let's look at the first one.
Background.
It's the background subtraction, right? You've seen this before. I showed you this a while ago, but again, so you're waiting for the frame to get still so you can get a reference. And then yeah, so how would you, how you'd say it is your hand in the foreground is different than what the reference had in the background, right?
Right. So the reference kind of normalizes it, and then anything new gets highlighted.
Yeah, I like the term normalizes. I like the term normalize. Maybe that's not technically correct, but I see what you're trying to say there. Because it's like, it's trying to set like, this is what the background is. And then, something changed in the background.
Yeah, that's what I meant.
Yeah, exactly. Normalize might be a good word. And then another thing to note here is the X's, right? Because
axis.
The X, it's dividing the screen into quadrants. And this is not part of the algorithm or anything. This is us just being able to, because if a user's playing a game, they want to move the controller. They want to either do left, right, up, down, something like that. So yeah, let's play a game and see how we do. And I think you can try this one.
Yeah, I'm not a gamer.
You got one. You got one. Yeah. Okay, so let's get this going here. So this is the rhythm game. So again, whatever directions the arrows point, if the arrows point in that way, you want to activate the right side of the screen. You can try to, remember using this thing right here. So give it a shot. Try to move something in the, try to activate the bottom.
Where's the arrow?
It's not on yet. But I'm just saying, like, for practice. Well, hey, don't use your finger. Use your hand. Use your hand.
Oh, yeah, you're right.
So now you're activating the bottom. So now you're in the top gun. And now you're in the right. You see what I'm saying? Yeah. So that's right activation. That's left activation. Bottom. Okay. All right. You seem ready. Okay. All right. Let's get it going here. Okay. Okay. Bottom. Try to get something bottom. You're on the left. Okay, you kind of got bottom. Now left.
Up.
Well, now it's up. Now it's up.
Left.
Down. Okay, you got down. Now left. Get your hand over here. Yeah. Now up.
Up.
Now right. Okay. You kind of got it. It could be a little different.
I didn't know the green is where I wanted to be.
Yeah, the green is the money zone, right? So left. Oh, you got it. There you go. You're pretty good. Okay, now you got it. Now you got it. Top. Right. Okay. Seems like you got it. Okay, that's fine. So yeah, like, how's your experience like playing?
Well, I learned how the virtual reality of my hand to use it to control it, and it really helped. So I thought it was really
okay.
fun.
Was it a pleasant experience or kind of unpleasant?
I thought it was pleasant.
Are you sure? I mean, be honest, because in our experience, we felt that it was pretty difficult to use, right? Because like, it's kind of hard to like get your hand in the right places, and then if you're like moving, there's a bunch of activations.
Well, I will say I'm not really good at that. Like even working on a keyless laptop.
Right.
And so yeah, but I obviously started knocking them.
You played the game a little bit, right? Yeah.
I think I could play better.
Yeah. Okay. Okay, that's good. So we talked enough about that. So let's do the different one. Let's do the other one. This is called KLT tracking. And yeah, so again, we talked about this before. Let's go over it again. We're thinking about tracking a point, and you see this little red dot right here is technically what's focused on, but
All right.
the application that we might have is for like our finger, if we want to like track our finger. So you can see it's kind of trying to, it got lost. What happened there actually is the skin tone of my hand in that area. I thought that my finger just moved really fast. If we point
Maybe I
this,
should try.
yeah, maybe your finger works a little better. Okay, so keep it still and try to move slow. This algorithm doesn't like big movements. Perfect, just like that. But you see how it's getting kind of, there it is. No,
Yeah,
it's
when
good.
you get up in the whiteness, certain backgrounds it doesn't like.
Well, certain backgrounds given a certain feature, right? Your skin obviously slightly pale tone, and then the walls are kind of matching that color. Yeah, you're trying to pick it back. I got you. Yeah, so it can track you, but you notice how it's kind of trying to track edges too, right?
Yeah,
See
yeah.
that thing right there? Like if we try to capture it, I bet it'll get stuck on the frame of the. Where are you?
The picture.
You see how it's kind of getting stuck on the picture frame?
A door or something.
It wants to, but it knows that. So what's going on there is it's saying that the frame has like a really distinct edge, so it thinks it's like a feature, but it knows that the edge is not really the feature area around the pixel is not really looking like my finger because the frame is like brown and my skin's like kind of white.
Yeah, well, I kind of understand that.
Kind of understand that. So actually, this is working pretty well now.
Yeah.
But you know, at my place, the thing that worked best is when you turn it to the sky, because we have a nice clear background, and it works pretty well here too in that area, especially. Oh, we lost it.
Well, you really explained it really good, Scott.
Yeah, you want to just like play a game real quick? Just
Yeah, let's do it quick.
Is this it? This one, you know, I expect to maybe have some difficulties with the noisy background, but we'll see. Okay, so, okay, oh, my mouse is dying, which means my computer's dying. Look at this. Oh no, my mouse is actually dying. Okay. Oh no, sorry about that. It's fine. Okay, so, geez, my mouse is really dying. Oh no. Okay, so go ahead and stick your finger up. Let's get you a point. Let's maybe point a little higher. Yeah, I guess a little higher. Okay, we're tracking. And now we're playing. So you know how to play this game, right?
Mhm.
Okay, so you want to try to put the red in the bottom. Oh no, it's lost your finger. Try to pick it up. Yeah, you got it in the right. Let's try to put it in the top. Move your hand higher. Your hand higher. Now move to the left. Oh, lost you. Yeah, you see, you try to pick it back up. There you go. Pretty good. Pretty good. Yeah, you're trying to get the dot in the quadrant relevant to the. Okay, you figured it out. Close, close. You got. Oh, almost got it. Almost. You technically get that one. Oh, this little ceiling's right on the quadrant.
Yeah, I know. So that's the
Yeah, that's tough. That's tough.
All right.
So yeah, you understand kind of what's going on with like corners and
If it
edges.
was a plain vanilla background, I think it would work a lot better.
Right. That's a big topic in this field, is the idea of like working with like, how do you determine like what's a feature? Like how, you know, you're given an image and it's like, well, you know, is this relevant? And you know, a major way that people do it is like edges. And again, I think the frame of the picture here was a good example because you know, that's a very sharp edge, is very distinct. We could express that mathematically. So we have that going on. And yeah, so basically we just wanted to show that there's like there's multiple different ways to play a game using like different machine vision techniques. These techniques are completely unrelated and they're used for different things. Background subtraction used for things like surveillance. You know, they have a picture, you know, like a courtyard and they want to see if someone like walked through. KLT tracking, maybe that's used for like highway. If they want to see how the traffic's flowing on the highway, each car will be a point, kind of like the red dot, and it wants to see how it moves along the highway. But yeah, so we were able to demonstrate, and some other applications we're thinking about too is just for like exercise programs, right? That could be pretty useful.
Oh, yeah.
You know, the rhythm games, you know, kind of get some movement, kind of get your body going. Yeah, I mean, anything else you want to know?
No, I think I'd like to try one of the games with a you know, more uniform background and really get into it. I think it could be really fun.
Brilliant, brilliant. Yeah, definitely the background is a huge issue, and that's one of our limitations here. And that was why we implemented this thing called color subtraction. But unfortunately, color subtraction is a little buggy right now on my end. You kind of need a very specific colored item. But other than that, it does filter out the noise in the background. Like we call this image noise and the picture noise. So I filter out all that noise and just track the difference. So
yeah, but I bet if you had it like uniform, it would be much more effective.
Exactly, especially in the KLT tracking. But that's one thing that our color subtracting does well.
Fun. Well, thank you for sharing that stuff.
All right, great. So I'll just end the recording now. Yeah, that's all. Thank you.